I can give you a quick introduction first about what load testing is. So yeah, we were just like chatting about product hunt and launches, but let's start with the application first. So we have an app. So this is an open source app I vibe coded a month ago for a hackathon to like, it's a judging app. So judges can submit scores, evaluate teams, and then deploy the stuff. So instead of like exchanging papers and like writing things down, they just use this app. So what we need to do load testing. So there are two kinds of testing that require like stimulating load on the application. One of them is load testing, which is actually we are simulating the realistic scenario where people are using our application. And we do that to make sure we size the resources properly. So how do we know how much resources we need when we're deploying an app to run this app smoothly? How do we know if we get an influx of users when there's like a peak or something that this actually application would scale to meet the demand? Will these resources be enough? Because if we get the resources right, then great, but most often we don't because it requires a lot of trial and error. I mean, you can calculate this. Like in practice, there are a lot of complications in these systems. So if you under like provision resources, you would end up like having downtime when users start coming in. And if you over provision resources, you'll end up paying a lot of money on the cloud service without getting like any ROI for this money you're paying, a return on your investment. So that's why we need to size things properly. And to be able to do this in a realistic scenario, we simulate load on the system, like creating a lot of web requests over a specific period of time. And then we see how the application behaves to be able to figure out, okay, so if we have 10,000 users making requests in parallel, this is how much resources we would need. And if we don't need this many resources, like if we have very few like people trying to use the app, we can scale down to this specific amount of resources so we don't waste money. That's why we do load testing. So we're going to deploy this app today. Actually already deployed it on ECS. So I use this very similar setup to the last ship it. So yeah, this is the hackathon judging app. It's protected by a password, but then like after you enter the password, if you can remember the password, okay. It's not super secure because like it's just a demo app. Yeah. What? It's the simplest password ever. Okay. I mean, you'd see this password hard-coded in the open source repository here. Anyway, it's not super secret. So yeah, after you deploy the app, so just like you pick up, like the judge picks their name, and then they evaluate the team, they give the team scores, and then they move on. In the end, you can see like there's a dashboard. So if you give it like here, I'm just giving you a rough idea of how this would look like. So you select random stuff. This is all vibe coded. So yeah, didn't take a lot of time. So you save the score and then it moves on to the next team. Okay, move on to the next team. Yeah, and then in the end, you can see, where is the dashboard? Oh, I can't remember. Where is the dashboard? Oh yeah, here. So you can view the scores for each team. And you can see the leaderboard, where you see like the top performing team in every single like aspect, like evaluation category. Yeah, so that's it. So this is one, like we deployed it on ECS. So to give you an idea of the architecture, I asked Stakpak to draw like an infrastructure architecture. It's not very pretty, but like it gives you an idea. So this is an AWS account on EU North 1. On a VPC, we have two availability zones. So two separate set of servers, like or two server farms to deploy this set. We have a subnet on each availability zone, two public subnets and two private subnets. And the public subnets I'm connecting to an ad gateway to be a public subnet. Actually, you have to connect them to an ad gateway. And the private subnets, and inside the private subnets, we have two ECS Fargate tasks running this Streamlit app on port 8501. It doesn't matter the port, but like they're just running within the private subnets, and they're exposed through an application load balancer in the public subnet. And that's it. We have a couple of things in addition. So we enabled container insights. So we enabled logs and metrics for these applications. And this is very important for load testing. Like if you're going to load test an application, you need to be able to inspect its memory and like CPU consumption and check its logs. Otherwise, you wouldn't know if something went wrong and when it went wrong. So if you're not taking note, or like if you're not recording the usage in the logs of the application, you can't make any decision based on what you see. I mean, if you increasingly like try to stress test an app, you just see go offline, but you wouldn't know why. Like, did it go offline because like you exceeded the CPU limit, so it's super slow, or did it exceed the memory, so it was killed? Like, you wouldn't know if you're not taking any metrics. So observability is super important. You have to connect some kind of observability before you load test, and that's it. So that's why we enabled insights and log retention and logs. And there's some autoscaling configured, so it's not very fancy, but if CPU consumption exceeds 70%, it's going to auto-scale up. And if memory consumption exceeds 80%, it's going to scale up. I limited intentionally the auto-scaling from 1 to 2 instances, because after load testing, we can try stress test this app, like see how far it can go before it breaks. As you saw, like it's already very slow. And here are some details about the architecture, but like as I mentioned, like these are deployed across 2 availability zones, so it should be more reliable. For a single instance, we gave it like half a CPU core and 1 gigabyte of memory. And initially it starts with like a single instance, not 2 instances. So horizontal auto-scaling is enabled, but it's not used by default. And yeah, the LB security group, and that's it. I mean, that's the important part. Okay, cool. Yeah. So do you have any questions about the architecture of the application before we proceed? I'm just checking up here. And please, like if you write anything down and when I'm not looking, like Noor is going to just like read it out loud. So yeah, before we start, I can give you like some examples of popular load testing tools. One of them is Artillery. It's Artillery. It's super old. I mean, relatively old, but it's amazing. Like you can now like get dashboards, write load testing scripts, and then run them, and you can simulate super advanced, like super complicated scenarios with Artillery scripts. I think Artillery is actually Node.js runtime, right? I don't remember. Like I didn't use it for a while, but yeah. And it has some integrations with like existing observability tools like OpenTelemetry and like Datadog, so you can hook it up with your observability stack to get the details you need or the results of the load testing to check the analysis. So this is a very popular tool, Artillery. And then there's also a K6 by Grafana Labs. So these are the same people that came up with the not the Elk stack, the LGTM stack for observabilities. They also built K6. I think K6 is in Go, but it actually runs JavaScript to test scenarios. So you write the scripts in JavaScript, but the runtime itself, I think, is written in Go. It's also open source like Artillery, and you can run these scripts. So in these scripts, you just simulate load. You can use API. You can define all kind of things. Like you can use GraphQL, WebSockets, whatever. You can use any protocol you need. And you define your custom scenarios in these scripts. So building load tests with these 2 tools, K6 and Artillery, are like writing unit tests. But these tests, or like the scenarios you write, are actually scaled up by the load testing tool into thousands of instances, as if thousands of users are making requests to your API. So as you can see here, like it's not enough to load test a single endpoint. What we're going to do here today is just load test the health endpoint, or like the main endpoint of the application. But in real life, or like in other scenarios, you would scale this by testing specific endpoints, because a specific endpoint can be connected to the database with an N+1 query or something, which could be super expensive to run. So you need to be able to load test different endpoints and different like application flow paths. That's why most of these tools support you writing these scenarios in a JavaScript or like a programming language of choice. You can also not use these frameworks and write tests and scale them yourself, but these make load testing easier. And my favorite classic tool is actually Apache Bench, which is just a CLI tool. This is the oldest one of them among the 3, but it's super helpful, it's super useful. It's available already on most systems. And this is the first one we're going to try here. If you have more time and based on what you want, we can demo the other tools as well. But Apache Bench is like the, yeah, I mean, you can do everything you can do with these other tools with Apache Bench and some bash scripts. So this is the simplest way to run a load test, but it's very effective. Yeah, so do you have any questions about these? I can also add the Apache Bench link if you want that. Yeah, Noor already did. Okay, cool. So any questions? Should we proceed to testing? Okay, amazing. Okay, so yeah, here. So first thing, we need the endpoint we're going to test. So let me know if you need me to zoom in more. But I found it hard. Like if I'm really zoomed in, you wouldn't see most of the logs. So just like scroll by. So yeah, so Stakpak agent. Let's load test this app. So we have like, what was the endpoint we're testing? So we can actually test the endpoint. This app using, oh, okay, we can actually ask it. Let's load test this app. Deployed with the setup in. Can actually reference the architecture here. Setup in ACS infra architecture. And monitor its resource utilization as we test. Okay, so first,
Mikhail has a question.
Yeah, so Stakpak is reading the architecture, but let's answer a question first. Would be very cool to dig deeper into artillery. Yeah, we can try doing that if we have more time. Like, let's start with Apache Bench because it's like the simplest. And if we have more time, we can like try artillery. Okay, so let's see. So first it analyzed the current architecture, and it knows some app details. So this is the URL we're going to test. The architecture is actually an ECS Fargate with an ALB. Current capacity is 1 to 2 instances. Like the allocated resources, the scaling targets, health check, and the container port. I'll help you load test the ECS application and monitor its resources utilization. Let me start by checking the current state of the application and set up monitoring. So at first it's checking the application to make sure this endpoint is working. So did we actually ask it to use Apache Bench, or did it come up with that? I don't remember. No, we didn't ask it. So it chose Apache Bench, which is great. Yeah. So it's looking for existing tools that I can use, and it found Apache Bench, but it didn't find work. I never used work before. Like, let's look that up. So work, load testing, a modern HTTP benchmarking tool. So this is a new tool. Interesting. Yeah, I've never tried this before. So just use Apache Bench for now. Start monitoring resource consumption, resource utilization. In the background, then run AB. Okay. It's assumed we were already running a task in the background, but we were not. But like, yeah, cool. No worries. So it came up with a convoluted command. So get metric statistics, getting CPU utilization. Okay, in the background. So it starts this as a background task. And it made a mistake. Okay, it's fixing the command. Now we have like a more elaborate command to monitor CPU utilization and memory utilization. So this is mostly like formatting, but let's see how it looks like. So we're going to check, like, instead of running the load bench, I want to make sure that like the task is displaying things properly. Okay, so here, yeah, so CPU utilization, memory utilization, running task count, desired task count. Okay, so the monitoring script is having issues. It's turning null for the service queries. Let me check the actual service name. Okay. Checking up the services. I found the judge app. Canceling the old task. So we added this background task runner because, as you see, like when you're trying to load test, or like most of the infrastructure tasks you do, require you to keep to run background tasks. Yeah, actually, I want to add something to this, like make the monitoring script print the utilization in every 10 seconds, for example, every 10 seconds, so we can check the history while we load test. So I wanted, instead of printing the current utilization, I wanted to print the utilization over time. Fix the service name, it's app, not hackathon app, based on this, yes, and to adjust the monitoring frequency to 10 seconds instead of 30. Cool. So every 10 seconds is going to log the utilization. So see now what happens is this is the CPU utilization table, and it prints the timestamp and the CPU utilization. So now we're running at 0.06% of the CPU capacity, and we have also the timestamp for the memory utilization table, and we're running at 15% memory consumption without doing anything. And this task is at we have only one instance. And now we're going to load test. So, okay, the monitoring script is now working correctly. The service name app I can see. So here, very low baseline and a stable memory utilization. And it's going to test with 10 concurrent users for 30 seconds. So here, N is the number of requests going to be made, and C is the number of concurrency. So 300 requests over 10 users in parallel. And this test is going to last over 30 seconds. So these are the three most basic parameters. So AB is going to do curl commands, or the equivalent of curl commands. 300 requests over a specific duration of time, because sometimes you want to simulate load over a period of time instead of having a spike in load. You want this load to be sustained, because if you have memory leakage or something like that, this wouldn't show immediately. You need to keep running for a while to see this kind of things. So that's why these tools are there. So this is the most basic way to simulate load over time, but you can have a lot of much more sophisticated scenarios. So while this runs for the next 30 seconds, we can answer questions about load testing if it would be interesting. See, the tool is copyrighted in 1996. That's how old Apache Bench is. Okay, finished 1,258 requests. I think it didn't do 300 requests per consumer. That's odd. I think I misread the parameters. But actually 300 times 10 are 3,000 requests. What did it do? Okay, so it started doing... Okay, no, I don't get that. Why did it do only 1,258 requests? Weird. So the baseline test is completed successfully. Let's see monitoring script. Okay, so yeah. So here the monitoring script kept logging things every 10 seconds. And I don't think the utilization changed much. Let's see Stakpak's analysis. Because it's very hard to see this without crunching the numbers. Okay, so the baseline test completed successfully. Here we have observed 10 concurrent users in 30 seconds. 1,058 requests over 30 seconds. The monitoring script is working correctly. So yeah, it's going to increase the load. So now we're going to do 1,500 requests over 50 users in parallel over 1 minute. I still not sure like how it calculated this. Like how did it end up doing that? We actually need to look up n, so we can do this. Then AB help, or we can ask Stakpak. But like let's check the manual like a regular pre-AI developer would do. So it's the total number of requests to perform. But I think this is like an upper bound because we did fewer requests. Okay. Yeah, so let's do like the medium load test. We'll keep increasing them until we break the app. So we're not stopping there. So Ali is asking, what are the differences between all these load testing platforms like K6, Artillery, and Apache Bench? So Apache Bench is the simplest, but Artillery and K6 give you more features. So you can create complex scenarios. For example, you can create a user that creates 3 or 4 requests and then prepares the payload for a more like demanding request and make this other request. So like you can have much more complex scenarios and complex models. Here it's just linear. So we're creating a lot of requests over a specific amount of time, and this amount of requests we're doing in parallel. Yeah, I think what happened here is like 50 users tried doing 1,500 requests in parallel over 1 minute. But if you're using K6 or Apache or Artillery, as you saw here, like in the code samples, you write code to build a scenario, and then K6, the runtime, runs the script in parallel. Okay, so here completed the request. That's the first one to measure baseline. And then for the medium test request results, it did 11,000 requests over 1 minute with 50 concurrent users. You see here CPU is peaking, unlike what happened before. So here, as you see, like there's significant increase in throughput, which is like 9 times the number of requests. And the CPU utilization actually spiked to almost 18% during this test, while memory remains stable. So what we can guess here is that Streamlit app is very CPU heavy. So now we haven't consumed a lot of memory so far. So this seems to be like a CPU bound task. So we'll continue to do that. But autoscaling was still not triggered because if you remember, we triggered CPU autoscaling at 70% like utilization of CPU and 80% utilization of memory. So let's keep going. So this is a high load test, 100 concurrent users for 90 seconds, each making like 3,000 requests. This is so much fun. Like, let me know if you're enjoying it, because I am enjoying it. Like, I love breaking applications. And did you think it would be that easy to load test an app? Like, just, I'm curious to know, like, was this how simple you expected it to be? $10,000 requests now? Okay, cool. Yeah, which tool? So Apache Bench is pretty simple, but I think the tricky part is being able to monitor effectively at the same, so observability at the same time as you are running the load test, and being able then to combine the results together, like get the result, the observability metrics, and then combine them with the actual test to come up with a conclusion. So before, when you do that, you have to do that manually. So you have to run the test and go to the observability solution to like do something like that. Like that's the product K6 is selling here with the paid version, is you actually get a dashboard where you can combine these results, but you can actually do it from a terminal like here. So yeah, so it ran the tests. So Apache Bench also shows you the latency of requests and the time taken per request and so on. But like, yeah, let's see the conclusions. Did the CPU spike more or no? Okay, so the high test results, we did 25,000 requests in 90 seconds, significant throughput increase. So this is like 300 requests per second. Average response time is 400 milliseconds, which is starting to get slower. CPU peaked at 17.88, which is odd because this is exactly the same number we got before. So I want to make sure this is actually right. So still no autoscaling triggered. Connection time, show latency, minimum latency, maximum. Oh, okay. So some requests actually took 4 seconds to complete, which is crazy. So we started to see more latency as we added more requests. Excellent. Results from high load test. Let me run one more stress test at 200 concurrent users. Yeah, so now this is like the highest gear. So 5,000 requests, 200 users in parallel over 2 minutes. And then I'm going to double check again the metrics because it feels weird that like we didn't exceed any CPU, like we didn't exceed the 18% CPU utilization. I didn't expect that. Like we get an awful latency, but I didn't expect to never exceed the 18% CPU utilization. So this is also another factor. Like latency can be a huge factor. So the CPU utilization could not be high, but we decide to add more cores because we need to finish more requests in parallel with low latency. So there can be a lot of things, like you can optimize for a lot of metrics when you're load testing, not just CPU and memory utilization. So this is like the most basic thing we can do, but you can also optimize for latency. So up to 20,000 requests. So I think I want to push this further. Like I think Stakpak settled for like this test with 200 concurrent users, but I want to see what if thousands of users are like voting on hackathons, how that would look like. I mean, this would never happen in real life, but like let's stress it. That's why it's a stress test. Like you should push it to the limit. So for those who just joined, what we're doing is we're stress testing this open source app I vibe coded, the Hackathon Judge app on ECS with Apache Bench, which is the simplest way we can stress test something. We're up to 35,000 requests. So this current scenario, what we're doing is we ask Stakpak to monitor the CPU and memory utilization of the service live in a background thread. And in the foreground, we're making 5,000 requests by 200 users in parallel over 2 minutes to stress the app. So we did 41,000 requests. Yeah, CPU peaked. So here, the key CPU utilization spikes. So highest peak during the stress test is actually, let's cancel the monitoring task first. Whoa, I did something stupid, okay. Can actually check it here in Stakpak. So let's see in our console. Okay, so we peaked at 42.5% CPU utilization, but the memory utilization remains stable. And as you remember, like what we're doing is we're just pinging this like root endpoint. We're not doing anything fancy. So we peaked at 42% CPU utilization, and the threshold is 70%. That's why it didn't auto scale. So we can try push it further. So try push it further. Monitor utilization again. We can actually add this time latency and latency if possible through ECS metrics. Try push these. Let's actually try with 1,000 concurrent users. Let's try break it. Yeah, please interrupt me and ask me any questions if you want. So the conclusions Stakpak came up with this is that we can go up to 350 requests per second. CPU peaked at 42.5%. No autoscaling was triggered. Memory remains stable at 15%. So we know we over provisioned memory here because the memory is just never exceeding 15%. But again, this is just load testing loading the main page. It might be when we make actual business logic requests that it would use more memory. Yeah, so it's starting an asynchronous command again in the background to monitor, to do monitoring enhanced with ALB target health. Okay, interesting. So CPU utilization. I'm not sure if we can measure yeah, I asked it actually to measure the latency, not target health, but I'm not sure if it can measure the latency from ECS metrics we enabled alone. I was not sure do we need to actually add more observability on ECS to be able to monitor that. So now we're going to try 1000 concurrent users. Okay. Yeah, there's actually an error here. I think it should fix that. So it's cancelling the whole script and rewriting again. So anyone here know if we can see the latency from the default ECS metrics? So Mikawi is asking on Stakpak CLI, which API do I need to provide OpenAI? No, you just need the Stakpak API key. So you can just go to our your Stakpak page, API keys, and a Stakpak API key. I mean, you don't need to configure any model, just that. Okay, rewriting the script again. Stack packing. Let's see if this finally breaks it. So Stakpak is calling it extreme stress test. Yeah, okay, it's working. But we didn't get latency. I really wanted to get the latency. Now running Apache Bench again. So 10,000 requests, 1,000 users over 3 minutes. That's fire. Okay, too many open files. I think we reached the limit of how many open connections we can run. So this is usually an error you get when you're not able to run many sockets. So what I'm going to do here is something interesting. So I'm going to ask Stakpak to split this onto multiple Apache Bench. I'm not sure if we can do this over multiple processes. So we can split it. So okay, split the AB stress testing command into multiple async tasks in parallel. So what I'm going to do here is I'm going to ask Stakpak to break the stress testing command into multiple commands that can be run in parallel on different threads. I'm not sure if this would fix it, but let's try.
George Mustafa is asking, what is our pricing model? Do we charge by using tokens, or we have a different model?
No, we actually charge you per request. So if you check our pricing page, you would see here there's a free tier with up to 20 requests per month. But then when you upgrade, you get 1,000 requests. So what is happening here? A single request is a single LLM response, regardless of how many tokens it uses. And we have multiple parallel tool calling enabled. So a single request from the LLM would just can do multiple things in parallel. Like this. Here, it split the load testing into 4 asynchronous tasks, and it started these 4 asynchronous tasks in the background. So this counts as a single request, even though it did 4 actions. So you get 1,000 requests for $50, but also like after that you pay like 10 cents per request, regardless of how many tokens you're using. Okay. So most of the tasks actually failed. We're going to see why now. Maybe I tried to hack my way around like the maximum number of ports I can open, sockets I can open. But yeah. So this is like an OS level bottleneck. Okay, so extreme test with 10,000 concurrent users is hitting the system limits on the testing machine, my machine. Too many open files. Even splitting into parallel tasks with 250 concurrent users each is failing due to the same system limitation. Let me cancel the monitoring task and provide a comprehensive analysis of load tests. Okay. So like, yeah, it's like Stakpak is telling me you're stupid. This doesn't solve the issue. You have to spin up multiple machines. So I can actually do something like...
Usually...
I'm very stubborn. Like I can...
We have some questions.
Okay, so we can answer the questions and then go back and try to do something. Does it support proxmox?
Yeah.
Yeah, I mean, it doesn't, like, it's not tool specific. You can ask it to use proxmox, or even like call an API. Like it can do web research. So you can give it like, you can ask it to research proxmox documentation, and it can come up back and use it with you. So it's not tool, it's tool agnostic. Like it's not specific to specific tools. Oh, nice. Claude cost me $10. Yeah, I mean, this session is definitely much cheaper than running it with Claude. So here we can do something fancy. So we can ask it actually to spin up multiple virtual machines and run these load testing across multiple virtual machines in parallel and try like do some sort of distributed denial of service attack on like on our own app, because I've reached the limitation of my machine. Like I can open more file descriptors. Interesting. So do you want to try? I think we have like less than 10 minutes left. What would you like to do? So would you like us to keep going, try to break the app and try to find a way around like the number of file descriptors limitation? Or would you want me, for example, to reduce the autoscaling threshold and see the app autoscale? Or should we try a different tool if we have some time?
Maybe you can make a vote.
Yeah, I don't have time to create a poll. Okay, yeah. So here, create a poll. What should we do next? Try K6 or artillery. Keep going, trying to break the app. With the app's resources. Okay, so here let's actually first read the documentation while you guys answer this. So yeah, so it has different CPU utilization peaks. During the medium load test, it peaked at 4%. During high load test, it peaked at 70%. During stress test, it peaked at 36%. The highest peak was 42%. Memory utilization remained 15, which is stable, which means we can reduce the memory. So the autoscaling behavior was never triggered because we never reached this like high number of usage. We got out of this system like 350 requests per second, and that's the best we got. And the latency, so the 50th percentile of latency is 300 milliseconds. The maximum latency we ever got was 4 seconds, but the 99th percentile, which means 99% of the requests when you make them, that's the highest. Like most of the time you would get almost a second in latency. So this is like how roughly it can get in like in usual like usage, because not all the requests would take 1 second, but like this is the like one of the worst case scenarios. And rate 0%, so we never failed. And the infrastructure observations, so single task handling, the application handles significant load with just a single ACS task. It's very efficient in terms of memory and CPU. The ALB health remained fine. So recommendations, so lower autoscaling thresholds. So Stakpak is recommending I lower the threshold to trigger autoscaling earlier because now we're handling load and it's still not scaling. Current max of 2 tasks may be insufficient due to high load scenarios. Performance optimization. The application shows good efficiency, but response times increase with load. So this is my observation earlier. So the utilization seems fine, but the latency grows high, which is a concern if you are concerned about latency. And the load testing environment, we couldn't do more than 10,000 concurrent users because of the descriptor limits. So if you want to scale this, we should do this across multiple machines. Or we should try doing it in a more clever way, other than like Apache Bench. I think some tools are able to do these concurrently without having multiple like ports or sockets open at the same time. So we can try doing more requests with the same concurrency, like with the same number of parallel users, but just like in a more efficient way, with more infrastructure. Okay, so let me show you the results. Try K6 arterially, play around with the app's resources. Okay, let's try K6 arterially. So if I have time, like, okay, so I don't have artillery installed, but let's see. So it's an npm. Okay. Let's see if Stakpak can install it properly. We can actually run it in Docker, right? Yeah. I haven't used artillery in ages, so we're going to see how that looks like. I don't think we'd have enough time, but like, yeah, maybe we can actually write a blog post or release a video about this if you're interested. Like, we can dig deeper into multiple ways you can load test and more information. Like, definitely we can go more deep than that in a blog post. But yeah, it's installing artillery globally with npm. Case 6 is more, yeah, so here, like this part about distributed load testing, this is what I mentioned. Like, you can go fancy and use 1000 parallel Lambda functions in a small duration to make a lot of requests and then scale them down. This is a very good use case for AWS Lambda because it's super cheap to run them and you can create thousands of instances in parallel. So this is like this kind of massive parallelization is very useful for distributed load testing. Okay, this is going to take some time. Let's see if case 6 like support this. So the documentation, it must support this, but like how easy it is it? Distributed. Oh my god, their search is terrible. Okay, it's searching across all Grafana products. And it's also super slow. Okay. So load testing. Okay. I can't find it, but I'm sure it supports that. So I think the cool thing about K6 here is that it can do correlation. I think it must tie back somehow to their observability stack. That's why they decided to build a load testing tool, because like, as I mentioned, like observability is super important because without it, you don't know the results of the test. Like, you can't make decisions. So it might be interesting to explore this further, like see how K6 ties back to the LGTM stack. Okay, it's taking a lot of time. We have 2 minutes left, so I really hope this, like, my download speed was much better. Okay. Yeah, guys, so we talked earlier about like Product Hunt. We're launching a product. This is our first ever Product Hunt launch. So we're launching this terminal agent on Product Hunt on Monday. So it'd be really helpful if you guys like check the launch and upvote us then. And again, like if you're interested in this, we would definitely write like a more detailed blog post about it. And if you have questions about like load testing your own applications, just like post them on Discord, and we'd love to help you. So here I asked Stakpak to create an artillery load test to replicate our Apache bench tests. So we have them codified. So here it created an artillery baseline configuration with the target phases of the load testing, because you can, as I said, like you can have much more complicated scenarios than what we already had. So the duration is 30, arrival rate is 10. I think arrival rate means like the number of parallel users, right? Okay. And it has a specific user agent, scenarios, basic health check. Okay. So it's basically everything with it, but in YAML. You can also write TypeScript, but I think YAML is better. But you can come up with much more complicated scenarios compared to Apache Bench, because Apache Bench is just linear. Like you can create phases with different load testing different endpoints to make create more complicated scenarios. But this is just like the basic setup. Okay, so a medium load test with more concurrent users and a bigger duration. And we're going to run all of them again. At first, we're asking hard to reach. If you skipped the entering API key at first, when asked, is hard to reach to load your API inside Stakpak API CLI. I'm not sure I'm following, but like if you don't enter it the first time, you can actually add it to an environment variable. So Stakpak API key, but you can also run the agent again, and like there's also a command like Stakpak login, which will also prompt you to add the API key. Okay, so the high test, that lasts for a minute and a half with 100 concurrent users.